to learn about severe weather, particularly lightning and tornadoes. We'll get to hurricanes tomorrow. Let's begin by learning about flash floods. Flash floods occur when rainfall or snowmelt exceeds the land's infiltration rate and or the carrying capacity of a river. Now, the infiltration rate is the rate at which the ground is able to soak up or absorb that water. Flash floods can occur in desert landscapes, valleys, coastal areas, and floodplains along rivers. Here in Wilkes County, we experience flash floods quite often, and sometimes it might even give us a delay in school, but rarely. Floods kill more people than any other natural disaster in the world. Okay, let's talk about thunderstorms. Thunderstorms are characterized by dark cumulonimbus clouds that produce heavy rain, sounds of thunder, flashes of lightning, strong winds, and sometimes even hail. Thunderstorms often occur in the summer when the air is warm, moist, and very unstable. These tend to occur along cold fronts. So where do thunderstorms form? Thunderstorms form along fronts because air is forced to rise and ahead of fronts called a squall line. Supercells are large single-celled thunderstorms with extremely strong updrafts. The updrafts rotate to form tornadoes. You can see the area circled in yellow where an updraft is beginning to form. You can see it's a large area with fronts occurring, and there's a little bit of a twist to them as well. So during thunderstorms, we can often find hail. But how does hail form? Hail forms by raindrops falling down to the ground. But as they fall, they then begin being sucked back up into the clouds due to the updraft. The updraft is warm air that is quickly rising into the cloud. As these water droplets rise back into the cloud, the higher and higher they get, the colder it gets, and suddenly it becomes so cold that the hail becomes frozen. Now, as they get frozen up at the top, they once again become heavy and they fall back down. However, as they fall towards the ground, the updraft catches them again and sends them back up into the cloud. As they return back up into the cloud, they freeze again, becoming larger and larger. Once the hail is too large to hold in the cloud, it falls to earth. This is why we can have different sizes of hail. Some as small as little pebbles, and some as large as golf balls and baseballs even. So let's talk about tornadoes. Tornadoes are a low-pressure storm that usually forms over land. In an average year, 800 tornadoes are reported in the United States. A tornado is identified as a violently rotating column of air extending from a thunderstorm to the ground. The rotating column of air is called a vortex. The vortex is only visible when debris and dirt gets carried up with the winds. If it was not for this debris, dust, and dirt, you would be unable to see a tornado. Oh, there it goes, Toto. If you look at the picture to the bottom right, you will see something that we call the hook. The hook is the flare of a tornado. When we see that hook, we realize a tornado is about to form, and we'll have a tornado watch. Hopefully, it will not turn into a tornado warning. So where do they come from? Tornadoes come from the energy released in a thunderstorm. What makes them dangerous as compared to hurricanes is that their energy is concentrated on a small area, only 100 yards across. The most common place for tornadoes to occur in the United States is east of the Rocky Mountains and west of the Appalachian Mountains. Now, this does not mean that tornadoes will not occur in other areas. We do still have tornadoes here in North Carolina and even in Wilkes County, but mostly they occur in the Midwest, especially along the area that we call Tornado Alley. It's that very dark area on the map. They occur mostly during the spring and summer between April and June. And they occur usually very late in the afternoon or early evening. And they usually occur along a cold front. After all, a cold front's where the thunderstorms occur, and thunderstorms produce tornadoes. How long is a tornado usually on the ground? Well, it varies. They can range from a few seconds to several hours, but most only hang around for about 5 minutes. How fast do they move? Well, that can range as well. Movement can range from virtually stationary, which means not moving hardly at all, to more than 60 miles an hour. Most, however, only move 10 to 20 miles per hour as they move from one area to the next. I want you to look at this photo. In this photo, we have a picture of the path of a tornado. Do you see the tornado's path? Look to the left side of your screen. Do you see it now? It is a diagonal line from the bottom left corner to the upper center of your screen. Now, there are 2 different notifications you need to be aware of. A tornado watch, which means conditions are favorable for a tornado to develop, but a tornado actually hasn't occurred. And warning. A tornado warning means that there is a tornado on the ground and you need to seek cover. The wind. Take a look at this piece of wood that was driven into a palm tree. A tornado threw this wood through that palm tree. This shows the power of the tornado. Now look at these. Wow. Is that a fork? Wow, a record in a wooden pole? I think that's a phone post. Now, as with most major storms, we measured the destruction of a tornado. We use the enhanced food. Oh goodness, I hope I don't say this incorrectly again. Fuda scale? I probably didn't say that correctly. But anyway, this rates tornadoes based on the amount and type of wind damage produced. We call these EF scales for short. If the tornado is an EF scale of 0, there's very light damage. If you look at this building, you will see that it's missing just a few shingles. The wind from an EF0 tornado can be between 65 and 85 miles per hour. It might cause some damage to siding or shingles, or maybe no damage at all. An EF1 is moderate damage. The winds are between 86 to 110 miles per hour. This can cause considerable roof damage. Winds can uproot trees and overturn single-wide mobile homes. And it can also cause flagpoles to bend. Oh, I hope they have insurance. EF2 is considerable damage. Winds between 111 to 135 miles per hour. Most single-wide mobile homes would be completely destroyed, Permanent homes can shift off their foundations and flagpoles can collapse, while the bark off of softwood trees can be ripped off. Look at this school. This school was torn apart by an EF2 tornado. An EF3 can cause severe damage. Winds up to 136 to 165 miles per hour. Hardwood trees can be completely debarked, and all but some portions of houses will be destroyed. An EF4 is some of the most devastating damage that you can find. Winds between 166 to 200 miles per hour, complete destruction of well-built residences, and large sections of school buildings. And last but not least, EF5. With an EF5 tornado, you have winds of over 200 miles per hour. And with this, there's usually nothing left. It's the most devastating type of tornado out there. You'll have significant structural deformation of mid and high-rise buildings, and strong frame houses will be leveled off their foundations and swept away. Cars become missiles as they fly through the air and travel hundreds of yards. This picture is a picture from 2008, where catastrophic damage was reported in Parkersburg as much of the town was destroyed, with reports of flattened houses and debarked trees. 6 people lost their lives, and at least 2 fatalities were reported where a housing development was destroyed, and at least 70 people were injured. Look at this picture. The home is no longer there. This is another picture of an EF5 tornado. This tornado occurred on May 4th, 2007. In Greensburg, the tornado was estimated to be 1.7 miles in width and traveled for nearly 22 miles. 95% of the city was confirmed to be destroyed, with the other 5% being severely damaged. The National Weather Service estimated winds of the tornado reached 205 miles an hour. This was the first ever tornado to be rated an EF5 since the updated Fujita scale. Fujita scale? I don't know. And it's just devastating.